So we've already talked about how to decide if a set of data points has a strong positive or negative correlation. Well, if they have a strong positive or negative correlation, that means that the points generally fall in a straight line. Now, if the points fall in a straight line, that means that there must be an equation that comes out of it. So we want to find what's called the regression line, or as sometimes known as the line of best fit. So this is something that should mean something a little bit from your previous algebra studies. You should be familiar with y equals mx plus b. You probably haven't talked about it for a long time, and it doesn't come up often, but y equals mx plus b was the equation of well, it was a linear equation. Remember, m was the slope, which represented a rate of change, the rate of change in y compared to 1 unit of x, and b was the y-intercept. So if I look at this graph that I have here, my y-intercept is 2, because that's where it crosses the y-axis. And my slope, remember from rise over run, from one point to the other is maybe up to over 2. So it has a slope of 1. So my equation would have been y equals 1x plus 2. Well, that's all great. However, we've got points that don't necessarily all fall on a line. So what we're looking at is another way of representing it. So in statistics, we have a slightly different form of the equation, although it all has the same pieces. We call it y hat, which if you remember, a hat basically means a sample. So a sample y would be b sub 0, which represents the intercept. So similar to the b in our y equals mx plus b. And then b sub 1x, b sub 1 is our slope. And as you can see, we've got two separate formulas down here for b sub 1 and b sub 0, all using the same types of calculations that we saw for calculating the correlation coefficient. So let's take a look at how we can use those to find the equation of a line. So, and I apologize if you hear my dog in the background. So as we look here, this is back to our equation where we had the number of errors in terms of the time spent editing an essay. All right, so as we look at that, if you go back to what we had previously in terms of our sums, we had the sum of the x's was 56, the sum of the y's was 59, x squared 794, y squared 889, and xy was 503. So we're going to use those to calculate what we've got going on here. So b sub 1 is n, so we had 5 data points, times the sum of xy, 503, minus the sum of x, 56, times the sum of y, 59, that's my numerator, over n times the sum of x squared, 794, minus the sum of x, 56, squared. Okay, so you again can do that calculation. I just need to find where mine is, and there it is. So on the numerator, I get negative 789. The denominator, I get 834, which gives me b sub 1 of negative 0.95. That's my slope. Then I'm going to do the same thing for b sub 0. Okay, sum of the y's, which is 59, times the sum of x squared, 794, minus the sum of x, 56, times the sum of xy, 503, over n times the sum of x squared, 794, minus the sum of x, squared, which is 56 squared. All right, so you're seeing the denominator's the same, so 834. The numerator, when I calculate that, gives me 18,678, which gives me, what is that, 22. So my equation is y equals mx plus b type of thing. So slope, negative 0.95x plus b sub 0, 22. Now, one of the ideas here is that you can use this then to make predictions. So use the line of least squares to predict the number of errors, which was y, by a student who spends 17 minutes editing her essay. So the idea here is you just now will substitute in that x value. So negative 0.95 times 17 plus 22. Let me check, gives me 5.85 errors. Okay. All right, like I said before, feel free to pause if you need to, but we're going to move on to another example. Okay, so this table shows the number of kilograms of chocolate eaten in a country compared to the number of Nobel Prize winners from that country. So likely not a whole lot of correlation here, but we'll see. So as we go through this, I have the chocolate, the Nobel Prize winners, and this time, just to kind of speed things up, I gave the sums instead of filling out the table. So we're going to use the formula to find R. So R is equal to, so I'm using this giant formula here, N. So I've got 5 different sets of data. So N is 5. So we've got 5. Whoops, times the sum of xy, which is the 159, minus the sum of x times the sum of y. That's my numerator. Denominator, first square root n, so that's 5, times the sum of x squared, 118, minus the sum of x, oops, 24 squared, times a separate square root n, times the sum of y squared, minus the sum of y squared. Okay, again, do it separately. So the numerator is 51. Denominator turns out to be rounded 64.16, gives me a 0.79. So as an R value, that's even a little bit higher than I would have expected because we're looking still at a positive. I don't think it falls in the range with that critical value, but still a little bit higher than I would have thought. Okay, so using that same idea, again, pausing the video if you need to. Now we're going to find the equation of the line. So here's my table again. All right, I want to find B1 and B sub 0. Remember, B1 is my slope. B0 is the intercept. Okay, so B1, B sub 1, equals N times the sum of xy minus the sum of x times the sum of y over n, so 5, times the sum of x squared minus the sum of x squared. Gives me 51 over 14, which is 3.64. Doing the same thing then for b sub 0. Remember that denominator is going to be the same, but in the numerator, the sum of y, 31, times the sum of x squared, 118, minus the sum of x times the sum of xy over denominators the same as in the previous example. Okay, so this time numerator is negative 158, denominator is 14. Turns out to be negative 11.29. Okay, so kind of y equals mx plus b. So y equals the slope times x plus or minus, in this case, the y-intercept. Okay, then to make our prediction, we are going to go with, for a country that consumes 10 kilograms of chocolate, that's my x. So we're going to do y equals 3.64 times x, which is, whoops, 10 minus 11.29. So when we do that, that one I did not do ahead of time. So give me a second. 3.64 times 10 minus 11.29. We would expect about 25 Nobel Prize winners if a country consumes 10 kilograms of chocolate per capita. Okay, so not a real practical example here, but one that hopefully is just a little bit interesting. So again, these formulas are directions. Really just use them as such. There's other courses that talk about how we get those formulas. That is way beyond the scope of what we need here. You are just using them as a set of rules. If you have any questions, please don't hesitate to send them to me. And hopefully that made sense. I would suggest that you practice it a couple of times just to make sure that you can use your calculator. Thanks.